Uh, Hi everyone, I'm Roshan. So I'll be presenting ThermoVR, exploring integrated thermal haptic feedback with head-mounted displays. And this work was done in collaboration with my colleagues, Zikun, Peng, Liwei, and Kouta Minamizawa from KO Media Design and also National Chiao University. So we also had a interactivity demo. I hope you had a chance to experience it. So let me tell you more details about our work. So as we know, recently there's been a lot of interest and a lot of popularity towards head-mounted displays. And recently, a lot of research has started integrating haptics directly with the head-mounted displays. And for example, GyroVR, which uses inertial forces with the HMD, and ambiotherm, which you may have seen yesterday, which uses ambient temperature and wind sensations on the face, and other vibrotactile integrations integrated with the head-mounted displays. So in ThermoVR, what we are more interested is in presenting thermal feedback directly onto the face, integrated with a head-mounted display. So we integrated 5 thermal modules onto the facial interface of a Oculus DK1 HMD, and our main motivations here was because the face is one of the most thermally sensitive locations on the body. And so we wanted to explore by co-locating thermal and visual feedback directly with the HMD, what kind of content we can create. So to explain about the system setup, each thermal module has 4 Peltier modules that are integrated inside the module. So Peltier modules can actively heat and cool in order to give the heating and cooling sensation. So as you can see in this thermal image, you can see the diagonal Peltiers are used for heating and cooling in our modules. But when you provide this the diagonal heating or cooling, but you still feel the temperature as a whole on the surface of the module. So we use an integrated a circuit attached at the back at the back of the head-mounted display, which has a temperature controller in order to control each of these modules that are capable of providing active heating and cooling sensations directly on these locations on the face. So in order to evaluate this, we conducted 2 user studies. So in the first study, what we were mainly interested was in providing was in identifying the accuracy of the perception when providing thermal stimuli. So for this, we provided 9 types of spatial thermal stimuli. For example, left top would be activating this module, top spatial cue would be activating all 3 modules, so on and so forth. And the participants use a simple interface like this, where when they click start, they can feel the stimuli, and then they report their results as to where the stimuli came from. And we gave hot and cold stimuli, and all the stimuli was 3 Celsius per second for heating or cooling, and was given for 1 second as a pulse. And so we gave in total 90 cues with 5 repetitions. So from the results, we interestingly found that the cold stimuli was perceived significantly better than the hot stimuli. This was quite interesting, where they said in these results you can see that for the hot stimuli, mostly on the forehead itself, they confuse a lot of the stimuli as in terms of the perception. So this was reflected in most of the participants' feedback, where they said the forehead was particularly difficult because it felt like the heat stimuli was kind of spreading across the face, across the forehead. But they enjoyed the cold stimuli, and the hot stimuli was not very popular, where they called it something like a hot pinch, or like different, or like even uncomfortable in certain cases, especially for the modules that are placed under the eye. So for the second study, we were more curious about the immersive characteristics of the of our ThermoVR setup. So we gave 2 visuals with our setup, and we activated all the modules in order to give full immersive thermal stimuli with the visuals. So we had 3 conditions: no stimuli, hot stimuli, and cold stimuli. And in this case also, we used 3 Celsius per second as the stimuli for 1 second, and then we maintained that temperature for 5 seconds for the user study. So in this case, especially for the thermal aspects, and we used the presence questionnaire, modified version of the presence questionnaire for evaluating this, and we found that especially for the thermal aspects or the sensory factors, we found that when providing hot and cold stimuli, the immersion perspective was higher. And we also noted that the visuals did not have so much of an effect on the thermal perspective perception, even though some of the participants mentioned that this could be because once they feel the thermal stimuli, after if they get without any thermal stimuli, the visuals seem even in some cases like boring. So for the feedback of the study too, most of the participants said they enjoyed the thermal immersion study, and they said like it reminded them of situations like opening an oven and feeling the heat on the face. And even for the cold sensation, some said like it felt like water. And one participant during one of the demos, she said like, did you actually spray water on my face? And especially when we had some related visuals for that demo. So to demonstrate these studies, we made 2 applications where in the first case it's using the thermal stimuli in order to guide a user towards finding a campfire in a very cold situation. So before it gets too cold, the user is supposed to find the camp and feel more comfortable when they reach the camp. And in the second demo, we wanted to show the immersion characteristic where we wanted to give not just see, but also feel the weather directly on your face. So we gave weather information and thermal haptic information together with them. And yeah, so as the future works, we are trying to improve the design because a lot of the participants complained that, not complained, but they mentioned that it was not very comfortable. And so we are planning, we are trying to improve the design to make it more comfortable and also expand the thermal stimuli range into temporal integration and temporal and integrating the head movements as well. So, and more importantly, we want to create these realistic feelings like rain, liquid, and even wind kind of sensations because the thermal sensation is at the base of these sensations that we perceive. So we want to create rain or liquid sensations without water, and we want to try to create wind maybe without fans. So that's it for our presentation. So. While I take any questions, I'll show you some of our recent works where the user is traversing through a kitchen, opening the fridge and feeling the coolness, and maybe going to the store, cooking some food, and feeling the heat on the face, and so on and so forth. So thank you very much.
Thanks, Roshan. We have time for just one very quick question. Thank you.
Hi, Jordan Toole from City University of London. Great talk. I really like how you integrated the temperature unit into the HMD display. I just wondered, you mentioned that you increased and decreased the temperature from the resting skin temperature.
Yes.
Does that mean you calibrated each skin temperature based on each participant's own resting skin temperature?
So yeah, this is actually something we tried out. So we did not do any calibration at the beginning. So from an off state, we just go into 3 Celsius per second actuation as the pulse. So wherever the resting skin temperature is, and we activate it from there. And we found out that like it still worked well without maintaining a starting temperature.
Okay, thanks.
Thank you.